All right, we're going to talk about parallel lines and proportional parts. And so we have a theorem that tells us that if a line is parallel to one side of a triangle and it intersects the other two sides in two distinct points, then it separates these sides into segments of proportional lengths. So what does that mean? Okay, so we've got a parallel line right here, and we have a parallel line right here. So those are our two parallel lines that intersect a triangle. So they're intersecting at these 2 points. And then basically it just tells us that those sides then are going to be proportional if you have those parallel lines connecting them. Okay, so it's telling us that CB, so C to B is proportional to C to A. Okay, so then CD has got to be proportional to CE. So let's fill that in. Okay, and so we're going to learn all these sides are proportional to each other. So BA, B to A is proportional to C to A. So then D to E is proportional to C to E. C to B is proportional to B to A. So C to D is proportional to C to E. So hopefully you can sort of see these fairly easy. BA is proportional to DE. So then C to A has to be proportional to C to E. And so you can use any of those. It's just given whatever information that you have. You can use any of those proportionals that you know that those two sides are going to be proportional to each other. So we can now look at some examples and find the value of x. Well, we know basically all this stuff is proportional to each other. So let's just set up a proportion here. X is to 1. So that's this is to this. As 8 then would be to the 2, and that's one of the ones that we're told up above. I think it would be this example. And now we're just going to cross multiply. So 2 times x is 2x, and that should be equal to 8 times 1, which is 8. So we're going to divide both sides by 2, so x would have to equal 4. All right, so we're going to set up another one. Find the value of x in this one. So we can do the same thing. We've got our two parallel lines right here. So we know 3 has got to be proportional to 5 plus x, as 4 is to 8 plus x. Okay, we're going to cross and multiply. And remember, when you cross and multiply, that means you're multiplying the entire unit by that other entire unit. So 3 times the 8 plus x is equal to the 4 times the 5 plus x. And remember, you have to distribute that 3 to everything inside those parentheses. So 24 plus 3x is equal to, distributing that 4 to everything inside those parentheses, 20 plus 4x. All right, and so now all we're going to do is solve for x. So we're going to move that 3x over to the other side. That just leaves us with x plus 20 is equal to 24 is all we have left over there. So we'll just move our 20 over, and that leaves us with x on this side is equal to 4. Final answer. All right, let's do a couple more. So we're going to do the converse of this theorem also, and that tells us that if these corresponding segments are proportional, then those two lines would be parallel to each other. So we're trying to determine if they are parallel. So we're going to label the information that they give us. So we've got triangle EFG. And they're telling us from E to G is 15. Well, E to G, that's the whole length, is 15. And e to h is 5. So I'm going to stick the 5 inside there, okay, for the e to h. L to g, so just this portion, is 12. And then F to L is 6. Okay, well, we don't have the same kind of sides here. So let's do a little calculation. If this E to G is 15, this one is 5, then H to G must be that difference, so that's got to be 10. So hopefully you see that. So the 10, H to G, plus the 5, E to H, adds up to be that 15 for E to G. And so now we can set those proportions up. So we can say, let's see, we want to say FL, let's just write it out, is to LG. So that should be EH would be proportional to HG. So let's set it up that way. So F to L is 6, L to G is 12, and that's going to be proportional to E to H, which is 5, and H to G, which is 10. Okay, so all we're going to do is cross multiply here. Remember, you're not solving for anything here. We're just going to say that if these two proportions are the same, then we can prove that those lines are parallel. So it's the converse of that original theorem that we just did on the other page. And we're just going to see. So 6 times 10 should be equal to 5 times 12, cross multiplying. So 6 times 10 is, let me just go up here, 60. And that's 5 times 12, which is 60. So yes, those two lines are parallel. So now we can say because of that, we know for sure that HL, this line is parallel, and that's the symbol for parallel, EF, to line EF. So yes, we proved that because those proportions are the same. Okay, so let's do another one here. All right, A to C, that's the whole length here, is 30. And A to E is 22. A to D, just this portion, is 10. And E to B is x plus 4. Okay, so again, we can do that, set those proportions up. So it's really very helpful to make sure that you label all of these so that you can make sure you're comparing the same thing with the same thing. Okay, so like in this example, we're given A to C, but we're not given this whole thing here, A to B. So we're given those two links separately, so we've got to make sure that we have the two links separately on this one also. So if the whole thing is 30 and A to D is 10, then D to C has to be 20. Okay, so now we can compare, sort of apples to apples and oranges to oranges, right? So let's go. C to D is proportional to DA, as then that would be B to E to EA. Okay, and remember, if they do not equal, then they're not proportional, so therefore those CB and DE are two lines here that we're trying to prove are parallel. These are the ones we're trying to prove that these two are parallel to each other. Okay. All right, so C to D is 20. D to A is 10. B to E is the x plus 4. And A to E is 22. Okay, so let's cross multiply. We're going to need a little more room maybe over here, but we've got 20 times 22 is equal to 10 times the x plus 4. So 20 times 22 is 440, and that's distributing the 10 over here, so that's 10x plus 40. We'll subtract the 40. So that leaves us with 10x is equal to 400 divide both sides by the 10, getting the x by itself. So x is 40. Okay, so, all right, so that's all we had to do on that one. We find x so that we prove that those are parallel. And that's all we had to do. So x is 40. Okay, the next theorem is a segment whose endpoints are the midpoints of two sides of a triangle is parallel to the third side of the triangle, and its length is half of the length of the third side. Okay, so I think what that is trying to tell us is that this, if we know that these two are the same, then this is the same, so this would be considered a midpoint here. We know that then that this line is going to be 2 times this line. So we should be able to say x plus 11 would be equal to 2 times the 4x minus 5. Okay, so this line, the x plus 11, is the half of the 4x plus 5. So 2 times the 4x plus 5 should equal the x plus 11. And in this instance, we're going to find the values of x and the value of y. So let's go ahead and do this one first because this is our theorem that we're learning. Remember, distribute the 2, 8x minus 10. Let's solve for x by getting those x's together. That leaves us with 7x minus 10. Add the 10 to both sides. 7x is equal to 21. Divide both sides by 7. So x is 3. Okay, so then we know that these two, in order to solve for the y, these two sides, this tells us that they are equal to each other. They're the same lengths. So we're just going to set those two equal to each other. So 4y plus 6 is equal to 2y plus 18. All right, let's solve. So we're subtracting our 2y from both sides. So that gives us 2y plus 6 is equal to 18. We're going to subtract 6 from both sides. So 2y is equal to 12. Divide both sides by 2. So y is 6. And we found both of those. Okay, now if the last one, I think it's going to tell us, and I may just do one of these examples because I know the video is getting a little bit longer than what you're used to. But so it says, if 3 or more parallel lines intersect 2 transversals, then they cut off those transversals proportionally. Okay, so let's fill this out. If PQ is QR, or proportional to QR, then DE has to be proportional to EF. Or, and I'll just do it in a different color, if PQ is proportional to DE, then QR is also proportional to EF. Okay, so just remember you can set those up whichever one of those ways or whatever information that you have. Okay, so let's look at an example. So, and all of this is setting up proportions. So 5 is to 7 as x is to 9. Cross multiply. 7x is equal to 45. Divide both sides by 7. So x is 45/7, I guess. That should not reduce. Okay. That's a strange answer, but we'll take it. Okay. So the next one, we know we can set these up also. So 3, and first we're going to have to solve for the x. So 3 is to x as 4 is to x plus 3. Always make sure you start with the information that you have first. You can't set this x to the y and the x plus 3 to the 2y minus 5. That gives you two variables and you can't solve for that. So 4x is equal to 3 times the x plus 3. So 4x is equal to 3x plus 9. Subtract the 3x from both sides, you get x is equal to 9. So then, again, this is the information you know, so you want to make sure you set that up to solve for the y. So we're going to say this should be proportional to the y, as 4 is proportional to the 2y minus 5. So remember that all those were proportional based upon the theorem that we had earlier. So 4y is equal to 3 times the 2y minus 5. Let's do our algebra part here. And solve, whoops, getting ahead of myself. Minus 6y, so that's negative 2y is equal to negative 15. And divide both sides by negative 2. So negative divided by negative is a positive. 15 divided by 2 is 7.5, or 15 halves. It's fine to leave your answers like that. Okay, so we're told that all these are the same. So we're just going to set those equal to each other. So this theorem is that if you've got 3 parallel lines that cut off those congruent segments, then all those segments are equal to each other. So x plus 1 is equal to 2x minus 5. Let's solve for x. So x minus 5 is equal to 1. Add 5 to both sides. So x is 6. So hopefully some of this starts making sense when you start seeing things that are parallel to each other. They should be proportional. If you start seeing these signs that tell you everything, those are the same links, then you know you can set those equal to each other. So